Okay, hello students once again. So you took all that manual data in the last two videos. I realize that isn't very fun, but it's good to take some manual data and do some analysis on to sort of see the limits of your patience and sometimes what manual data taking can do in contrast with some automated data taking that we'll do now. So this is what we sort of left with in the high count rate example we did there. We had some counts coming in sort of in the 600s like this. Okay, so the question is, can we automate this process now? Well, it turns out we can. So what we do is we go back to the same software that we've been using for the gamma ray scintillation experiments, and remember the way it worked in that mode. The channels down here were mapped into voltages or gamma ray energies. So the output from the amplifier, that we see on the oscilloscope here was directly fed into the black data acquisition box right here, and they were digitized or converted to digital values. And of course the higher voltages fell in the higher channels, lower voltages fell in the lower channels. So for example, if we were taking a cesium-137 spectrum, we'd see a big photo peak rising up here, and the Compton continuum and so on down here, and all the rest lower energy stuff down there. That was very nice. But it turns out now you can use this box also to do some counting for you. Okay, so what we'll do first of all is down here on the electronics, we will take the output of the SCA, which is on this line here. We'll split it off into two ways like this. We'll put this T in here, or a splitter, whatever you want to call it. So we're going to still send it into, half of it into the scalar. So it's kind of reassuring to see the scalar run so we know that things are working. But the other half here, the other cable, we're just going to send into the black Pocket MCA data acquisition box. That way it's going to be routed up to our software via the USB interface on the computer. So there we go. And we wouldn't want to run it now because remember that the voltages coming in from the SCA are all the same voltage, so there'll be just some bin, they'd all grow out. Let me just run it run it here and just see what we get. Did we get anything here? Remember they're 5-volt pulses, and just curious if we get anything on here at all. Maybe we're off scale or something. Yeah, so I'm not seeing anything here. I don't know, maybe it's, I don't know what's happening. I'm not seeing anything at all, but it isn't the quite right mode for it to send these pulses into this system here. So let's just stop it here and clear it. I did see a long line, maybe due to way over here. So it looks like all those pulses are sort of getting bunched up into channel 0. Okay, anyway, what we do, we go into the acquisition setup over here and go to MCA again. And it turns out if we go over here, remember there was this two modes that we were using. There's norm and MCS over here on the software. So norm is the normal mode, the pulse height analyzer that we use for our classic scintillation. That's the one that throws the voltage into the channels the way I just described. But it turns out there's another mode here called MCS. It stands for multi-channel scalar. Multi-channel scalar. And let me just tell you what that does. So I'll leave it there on MCS for a minute. I'm going to come back to this menu after I show you something. But we've changed the modes. And so what happens now is these channels are no longer going to be voltages anymore. They're not going to represent high and low voltages that we see here. What they're going to represent now is each channel is going to take on a little delta t called the dwell time. So channel 0, the computer will sit there for some time we can set and count how many pulses it sees coming in on that little black box right there. Okay, so it's going to count those pulses and say it gets 5. It'll draw bar 5 units high in that bin, in that channel. Then it'll go to the next channel, channel 2. Wait for some time and count again. Say it gets 10. It'll draw bar 10 units high in that bin, in channel 3, in channel 4, and so it goes on and on. So each of these channels here now becomes a time delay, not an energy or a voltage. That's what MCS mode stands for, multi-channel scalar. Remember, this thing was called a scalar here, only one channel because you only have one readout. This is also a scalar, but there's multiple channels because you have 8,000 channels all the way across the display there. So the only other thing I need to set, I told you I'd come back to the configuration here, is I didn't want to do that. I wanted to go to acquisition setup. I wanted to go to MCA. I wanted to go to the Timebase right here. It looks like it's already set to 1, so I'm in multi-channel scalar mode, and I'm going to tell it that in every channel on the x-axis, I want to wait for 1 second. That's the same Timebase we use down here, so it seems like 1 second works for us, so we'll just leave that. So every channel that we see now is going to represent how many times it sees a pulse from the SCA over a 1 second time interval. Okay, so let me just stop it. Now if I hit go, so it's running now, and what I'm seeing over here is basically a big line filled the screen there. Remember, we have 8,000 channels. I'm not really seeing anything at the moment, but a couple things. Remember, we're getting about in the 600s or so counts per second And so if I go back to the y-axis over here, I only have it scaled up to about 59, so I'm definitely going to have to change my y scale in order to see these things here. Let me just zoom in, maybe get that y up to the, there we go, something like that. See, okay, there's about 742, and so see that bar is just about in the 600s here. Now again, we have 8,000 channels across. I really can't see what's coming in, so let me just sort of rescale the x-axis also. And if I do that enough, let me just get down more, as far as I can go. It's the other way. Let's see. Oh yeah, I know. Let me just scroll over here. I hit the scroll bar, so I maxed out on the scale. So if I do this now, there we go. This is what I wanted to show here. So you see exactly what's going on. These are the counts that I'm getting. So as it ran, let me move this window out of the way here. As it ran, remember for 1 second, I got just under 593 counts, a little lower, a little higher. Then up here, I'm getting into the 600s, then a little lower, then a little higher. These are those bar heights that every channel on the MCS is bringing in for me. So if I scroll over just a tad bit here, we can sort of watch it run. Let me get that end in there again, if I can find it. Well, let me hit this now, there we go. Just want to let you see some of this data coming in. There we go, okay, so here we go. So see, alligator 1, it's counting, and drawing a line. That's exactly how many counts we see in the 1 second. So you see, the height of these bars here is exactly that number there, but just sort of all done for us. So we can just walk away from this thing and just let it count. You can see that data coming in. So it's kind of fun. And so what we'll do then is we won't sit here and watch this because there's 8,000 channels that goes all the way across. So let's see. This is just the way to take this data. You really love this. And so we'll I have it maxed out, so remember this is sort of where it's at right now, and this is channel 8,000 over there, so we're not going to wait. This takes about 2 hours or so to run, but in other words, we are going to collect these exact numbers for 2 hours, not just 4 minutes the way you did. So we're going to get 8,000 of these data points all automated for us by the computer. So we'll do it in 2 ways, of course, and we're not going to wait for this. I'm about to end here. We'll do the high count rate for 2 hours, we'll do the low count rate for 2 hours, and we'll just offer you up the data files. But I just wanted you to see that the computer will do some of this automated data taking for you. So there you go, the MCS. So you've now used an MCA in PHA mode and MCS mode.